Yeah, we're going to talk about turbidity for the next 20 minutes. We'll define what turbidity is and what it's all about. We'll look at some international standards and how they relate to the swimming pool industry and pool water testing. We'll look at influences on turbidity and why we should be doing some testing. We'll look at some instrumentation and a bit about the optics and why we need a turbidity meter. And then we'll look at some interferences and calibration and verification. And that should take, hopefully, about 20 minutes. So turbidity is all about cloudiness and haziness of water. So rather than looking at transmittance or absorbance, like we would do for some of the other tests like chlorine or pH, we're looking actually at how the light reflects or refracts or scatters from the particles within a sample. So we're measuring scattered light, and it's a key parameter for water quality monitoring, not only in swimming pools but in drinking water and wastewater and other applications too. So if you think about driving through fog, you can't really see much. Things could be hiding in the dark. It makes life pretty difficult to see what's going on. And so you can liken this a bit to looking at turbidity in pools. I got my friendly AI to do me a word cloud. And I did this based on our turbidity brochure, but also the PUTAG document. And so as you can see from the word cloud, it becomes clear that turbidity is involved in quite a lot of things regarding pool water quality management and water treatment. Now obviously we'll not go through them all in detail, but if you just look at that, it does bring home that actually turbidity is quite important. So we'll have a look at a few standards and why these relate to swimming pools. So for turbidity, you've really got two standards that we are interested in. You've got the ISO and you've got the EPA, Environmental Protection Agency from America. Now here in the UK, we conform to the ISO 7027 standard. As you can see, they're quite similar, and they both specify a 90-degree scattered light. So for drinking water standards here in the UK, we follow the ISO 7027, and these are actually the prescribed limits that the DWI state for drinking water. And so we're looking at treatment works. So every drinking water plant here in the UK must measure 1 NTU or below as it leaves the treatment works. And when it gets to a customer's tap, it should be 4 NTU or below. So if you've ever had the water company, your local water company, turn up and ask to do a sample of your water at home, they will be measuring, and it has to be below 4 NTU. Now, why is that sort of important in swimming pools? Well, if you look at the PUTAG recommendations, they're actually saying that it should be 0.5 NTU. So they're sort of following the drinking water standards here in the UK, but actually going a little bit further. So yeah, we're in the swimming pool industry, we're trying to basically beat what the drinking water is. And now why is that? Well, as we saw from that word cloud, there's quite a lot of things that can affect turbidity in a swimming pool. And these are just some of the key points that I thought would take from that word cloud and from the PUTAG document that influence turbidity or can have a reason why turbidity might increase. So again, there's quite a few different things going on there. Okay, so why should we be testing then? Well, turbidity can be an early warning system. So even if you're just doing a quick turbidity check, it can tell you a good indication of maybe other things that are going on in the swimming pool. whether it be something to do with the filtration or circulation, could be some contamination within there. It's a good, easy, quick check. One of the things that I read in the PewTag book was about underwater drowning protection systems, which I've not really come across much before, but it says that it's important that these are checked for turbidity because they rely on a good turbidity to work correctly. And also if you've got UV systems, UV disinfection systems, if you've got suspended particles in your water, that can scatter the light and render the UV systems, well, not as good as they should be working. Okay, let's have a look at some different kinds of instrumentation and test kits that we've got for turbidity. So here we've got a visual system, which is a turbidity tube. Now, if you guys have ever used a cyanuric acid test or a sulfate turbidity test in the swimming pool industry, then you'll be familiar with this kind of test kit. It's those two test kits are sort of a modified version of this turbidity tube. And basically the way the actual turbidity tube works for this application is just like you've seen the lady there. She's filled her sample up right to the top and letting it out through the bottom until there's a little spot on the bottom of the tube. And just as that either disappears or you can see it, you would read the result off the side of the tube. Or there's another version where you would start with the empty tube, fill it up, and again wait for the spot on or the cross on the bottom of the tube to disappear, and then you'd take your reading. Now that's good for field work, but really anything below sort of 20 NTU can't really visually differentiate. So you do need an electronic instrument. Something like this, a laboratory instrument or a portable instrument, but a specific dedicated turbidity instrument. Or you could have a process instrument. So again, in the drinking water industry, these are widespread. Not so much in the pool industry, but we have seen over the last couple of years a couple of them being installed in a couple of swimming pools here in the UK to monitor the filter performance. And these instruments would just sit on the wall and spit out data every so often so you can monitor the turbidity levels. Okay, so I've mentioned that you need a specific instrument for turbidity, but there are a couple of questions that we might need to answer. You might have a photometer that already has a turbidity measurement test on it, so why would you need a specific separate instrument? Well, if we just look back to the standards a minute, we'll go back to the 90-degree scattered light. So remember, we're looking at scattered light here. And if we think about a standard photometer that we've got for things like chlorine or pH or alkalinity, this is a sort of a diagram of the optics inside a standard spectro or a colorimeter or a photometer. The bit that we're interested in really is that bit there, where the light comes in, goes straight through the instrument and out the other side. And with standard photometers, that's how the optics are lined up. So you'd have your detector directly across from where the light goes in. With turbidity, it's different. So you will get light going straight through, but we're actually wanting to measure the scattered light. So your detector, which in a normal photometer will be here, your detector in the turbidity meter is at a 90-degree angle. So that's why you need a specific turbidity instrument. So, yeah, sorry if you've got one of your standard photometers for chlorine or pH or whatever. In this instance for turbidity, you need something different. So that's why you would need a standard specific turbidity meter that has the optics in it that you need. And then these meet the ISO standard. So just having a look a little bit more inside the instrument, this is a typical setup of what you might see. So your light is coming in and it's scattered down, and we've got, in this instrument, various detectors, but they're at 90 degrees. Now that's not always the case, you might just have one detector, but the important thing here is it's at 90 degrees. And you might also have other things in there like light traps to reduce the scattered light, which is another interferent in turbidity. But yeah, the important thing there is the 90 degrees. So let's have a look at some interferences then. So I've just mentioned a bit about stray light and the light traps that you need to reduce the stray light. Colour's an important interference in turbidity as well. But one of the standards say that the ISO standard says that you should use an infrared light source, and any infrared light source will negate any colour interference from your sample. So if you're following the ISO standard, which you should be, then you've got no colour interference in your sample. Other things settling out, so if you've got large particles and you're leaving your sample for quite a long time before you analyse it, it could be settling out, and that's going to give you an incorrect result. So sample preparation is quite an important thing when you're measuring turbidity. However, bubbles are also an interferent as well. So again, if you're preparing your sample and you're shaking it vigorously before you're doing your test, introducing bubbles, you're going to get an incorrect result. So yeah, sample preparation when you're doing these turbidity readings is very important. And then the other two interferences on here are typical to what you would find in a normal spectrophotometer or colorimeter for pH, conductivity, pH, DPD, phenol red, that kind of test as well. So yeah, if your instrumentation is dirty or if you've got condensation, then obviously you're going to get incorrect results. Okay, so unlike your other pool tests, like your DPDs and your phenol reds, these turbidity meters don't use tablet reagents. So all you're doing is you're physically measuring just the sample as it is. But like we've just seen, that sample preparation is quite important. What you still need to do though, just like the other tests, is make sure that the instrument's calibrated and make sure you're checking it regularly. So although you're not using consumables for every test, like a DPD tablet or a phenol red tablet, you would still have calibration solutions that you would run through the meter to make sure that the meter's working correctly. Now, a lot of the meters that you can get are already supplied with reference standards, so they come with the instrument, but you will have to buy them occasionally to make sure that your meter's still performing correctly. So yeah, we do a variety of different reference standards at different levels, so you can check your meters on a regular basis. Okay. Seem to have gone through that quite quickly, but there we go. So yeah, just as a summary then, so we're measuring scattered light, so it's different to the normal photometer test that we're doing on a daily basis. So you do need a specific instrument. There's different instruments available. We're probably talking mainly about the portable instruments. And it can be an early warning for other aspects of pool water treatment. You do need good sample preparation, so you do need to take your time over how you're doing the tests and make sure you're doing it correctly, and of course look after your equipment, which you can do with your reference standards and your calibration solutions. Okay, I hope that was okay. Thanks.